Say you want to repeat an experiment thousands of times. How do you do it? Using a computer. In today's video, I'm going to demonstrate some simple computational physics, and we're going to do it based upon an experiment where we flip coins until we get 50 heads in a row.
This is the code to my experiment. It begins by recording the start time. Then, while our longest streak of heads is below the target value of 50, it flips coins. The coin flipping is actually a random choice between two options of head or tail. If it turns out to be a head, one is added to the current streak. If it's a tail, we start over again. After every flip, the current streak is checked against the highest streak so far. If it is the new highest streak, it prints out the streak length and the time it took to achieve that streak. Let's run the code and see what happens. The first streak of 19 happens in just under a second. The first streak of 22 is just over a second. Then things start taking a long time. At just under the minute mark, we've reached a streak of 26. The 27 streak is reached just after 12 minutes. And at nearly 50 minutes, we've only reached a 30 streak.
Okay, this is starting to look like it's going to take a really long time. Perhaps we can write a second code to try and work out how long we expect to wait.
Here's the second code I used. The central section of the code is functionally very similar to the first code. However, the code has been expanded so that it reaches each streak multiple times and calculates the average time taken for each streak. Let's try running this code for streaks up to 10. The first few values don't reveal much, but after a while a pattern begins to emerge. If we take a closer look at the pattern, then maybe we can extrapolate some data. We begin by writing down the numbers from our experiment. We can see that each new number is roughly double of the previous number, which means our rule will be 2 to the power of something. So let's write down a sequence for 2 to the n, where n is an integer. If we compare our two sequences, we can see there is a way of connecting them together. And we can see that we need to shift our 2 to the n sequence 1 to the left. Now let's rewrite the original sequence with our new sequence of 2 to the n minus 1 below it. The numbers in the original sequence are about 2 less than the numbers in our latest sequence. This leads to a final answer of our sequence being approximately equal to 2 to the n minus 1 minus 2. By following a similar method with the times, we can deduce a linear relationship. Thus, to estimate the amount of time per flip, we can take a time and divide it by the number of flips, which gives us approximately 2.2 times 10 to the minus 6 seconds per flip. Then, if we multiply the expected number of flips, where we can ignore the minus 2 term because it is negligible compared to 2 to the power of 49, by the average time per flip, we find out that we should expect my computer to take just over 39 years to flip 50 heads in a row. I'm glad I didn't try to wait it out.